Determining the ambient temperature for conductor ampacity correction involves several factors. These factors contribute to the temperature, including firstly, outside air temperature, which is the temperature outside the building or conduit where the conductors are installed. Secondly, heat generated by equipment and lighting, where devices and fixtures within the building or enclosure can emit heat that raises the conductor temperature. Thirdly, solar radiation, where direct or indirect sunlight can heat conductors, especially if they are exposed outdoors or in attics. And fourthly, location, where conductors in enclosed spaces, such as underground or in conduit, may have higher ambient temperatures than those in open air. In the field, determining the ambient temperature for conductor ampacity correction is often an educated guess. Some common practices include firstly, measuring outside air temperature by using a thermometer to measure the temperature outside the building or enclosure. Secondly, using building conditions by assuming a higher ambient temperature for buildings with heavy electrical loads or where equipment generates significant heat. And thirdly, observing conductor temperature by touching or measuring the temperature of the conductors to assess their heat buildup. The National Electrical Code does not provide specific guidance on how to determine the ambient temperature for conductor ampacity correction. However, it does state that the allowable ampacity of a conductor should be derated based on the ambient temperature at the conductor operating temperature per National Electrical Code Section 310.15 Cone. Recommendations to follow include firstly, use judgment and experience by considering the specific conditions of the installation and use your best judgment to estimate the ambient temperature. Secondly, err on the side of caution by selecting a higher ambient temperature to ensure adequate ampacity derating if in doubt. Thirdly, measure if possible, measure the conductor temperature or outside air temperature to provide more accurate data if practical. Fourthly, follow manufacturer's instructions, where some conductor manufacturers provide specific guidelines for determining the ambient temperature in their product literature. Ultimately, the goal is to ensure that the conductor is not overloaded and can operate safely within its rated limits. It's important to understand the factors that influence ambient temperature, apply practical field practices, and adhere to code requirements to ensure safe and reliable electrical installations. Proper ambient temperature correction is crucial for preventing conductor overheating, insulation degradation, and potential fire hazards. When selecting conductors for a specific application, it is necessary to consider the ambient temperature in which the conductors will be installed. The allowable ampacity of a conductor, which is the maximum current it can carry without exceeding its temperature rating, is based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, the allowable ampacity of the conductor must be reduced to prevent overheating. The National Electrical Code provides tables of correction factors that can be used to determine the appropriate ampacity derating for various ambient temperatures. These tables are based on the type of insulation used on the conductor and the installation conditions. To determine the appropriate ambient temperature for conductor ampacity correction, it is necessary to consider all the factors that can contribute to the temperature of the conductors. These factors include firstly, the outside air temperature, which can be obtained from weather forecasts or by using a thermometer. Secondly, the heat generated by equipment and lighting, which can be estimated based on the power consumption of the equipment and lighting fixtures. Thirdly, solar radiation, which can be significant in areas with direct sunlight exposure. And fourthly, the location of the conductors, as conductors in enclosed spaces or underground may experience higher ambient temperatures. In the field, it is often difficult to accurately determine the ambient temperature. In these cases, it is best to err on the side of caution and select a higher ambient temperature to ensure adequate ampacity derating. It is also important to consider the potential for future changes in the ambient temperature, such as the addition of new equipment or lighting. Measuring the conductor temperature or outside air temperature can provide more accurate data for determining the appropriate ampacity derating. This can be done using a thermometer or thermal imaging camera. It is also important to follow the manufacturer's instructions for determining the ambient temperature, as some manufacturers may provide specific guidelines in their product literature. Ensuring that conductors are not overloaded and can operate safely within their rated limits is crucial for preventing electrical hazards. This can be achieved by carefully considering the ambient temperature and applying the appropriate ampacity correction factors. When working with electrical systems, safety should always be the top priority. By following these guidelines and adhering to the National Electrical Code, you can ensure that your electrical installations are safe and reliable. The ambient temperature surrounding a conductor significantly impacts its ability to dissipate heat. Higher ambient temperatures reduce the temperature difference between the conductor and its surroundings, hindering heat dissipation. This necessitates reducing the conductor's ampacity to prevent overheating and potential insulation damage. The National Electrical Code provides tables such as Table 310.16, which lists correction factors to adjust the allowable ampacity of conductors based on ambient temperature. These factors are applied to the base ampacity of the conductor, which is determined by its size and insulation type. Selecting the proper ambient temperature for ampacity correction is crucial for ensuring safe and reliable operation of electrical systems. Unfortunately, there is no single, universally accepted method for determining the correct ambient temperature. The choice depends on the specific installation conditions and requires careful consideration of several factors. These factors include, firstly, the average ambient temperature, which can be obtained from local weather data or historical records. It is important to consider both the average daily temperature and the potential for extreme temperatures. Secondly, the location of the conductor. Conductors installed in enclosed spaces, such as attics or underground ducts, will typically experience higher ambient temperatures than conductors installed in open air. Thirdly, the heat generated by nearby equipment. Equipment such as transformers, motors, and lighting fixtures can generate significant heat that can raise the ambient temperature in the surrounding area. And fourthly, solar radiation, which can significantly increase the temperature of conductors exposed to direct sunlight, especially in outdoor installations. In practice, determining the ambient temperature often involves a combination of measurement, estimation, and engineering judgment. It is essential to consider all relevant factors and to err on the side of caution when in doubt. Some common field practices for determining ambient temperature include: firstly, measuring the air temperature in the vicinity of the conductor using a thermometer or other temperature sensing device. This can provide a baseline for estimating the ambient temperature, but it is important to account for any additional heat sources that may be present. Secondly, consulting with experienced electricians or engineers who are familiar with local conditions and typical temperature profiles. Their expertise can be invaluable in estimating the appropriate ambient temperature for ampacity correction. Thirdly, using thermal imaging cameras to identify hotspots in areas of elevated temperature. This can help to pinpoint potential problem areas and to refine the ambient temperature estimate. And fourthly, monitoring the conductor temperature directly using temperature sensors or data loggers. This can provide a more accurate assessment of the actual temperature experienced by the conductor under load. While the National Electrical Code does not provide specific guidance on how to determine ambient temperature, it does emphasize the importance of considering all relevant factors. Section 310.15 currently states that the allowable ampacity of a conductor shall be corrected for ambient temperature conditions. This implies that the ambient temperature should be determined as accurately as possible, taking into account all potential heat sources and environmental factors. Some additional considerations for selecting the proper ambient temperature include: firstly, the type of insulation used on the conductor. Different insulation types have different temperature ratings, and the ampacity correction factors will vary accordingly. Secondly, the presence of multiple conductors in the same raceway or cable. When multiple conductors are installed together, they can generate additional heat, which can further reduce their ampacity. Thirdly, the potential for future changes in ambient temperature or load conditions. It is important to consider the possibility that the ambient temperature may increase in the future due to changes in weather patterns or the addition of new equipment. When in doubt, it is always best to err on the side of caution and select a higher ambient temperature for ampacity correction. This will ensure that the conductors are adequately protected and that the electrical system operates safely and reliably. In addition to the factors mentioned above, it is also important to consult with the conductor manufacturer's specifications and recommendations. Some manufacturers may provide specific guidance on how to determine the ambient temperature for their products. Ultimately, the selection of the proper ambient temperature for conductor ampacity correction is a matter of professional judgment and requires a thorough understanding of the installation conditions and the relevant code requirements. By carefully considering all relevant factors and erring on the side of caution, you can ensure that your electrical systems operate safely and reliably. Remember to consult with qualified electricians or engineers if you have any questions or concerns. A thorough understanding of these principles is essential for ensuring the safe and reliable operation of electrical systems. The principles are, firstly, accurate ambient temperature assessment, where properly evaluating ambient conditions is paramount for safety. Secondly, conservative dating where in doubt, always increase temperature for correction factors. Thirdly, consistent code compliance, making sure NEC guidelines are always followed for safe installations. Electrical safety is paramount, and correctly determining ambient temperature for conductor ampacity is a cornerstone of safe electrical practices. Always prioritize safety and seek expert advice when needed to protect lives and property. Consider a scenario where conductors are installed in a hot attic in Florida. The outside air temperature during the summer can easily reach 95 degrees Fahrenheit or 35 degrees Celsius. The attic itself can become even hotter due to solar radiation and poor ventilation. In this case, it would be prudent to assume an ambient temperature of at least 122 degrees Fahrenheit or 50 degrees Celsius for ampacity correction purposes. This would ensure that the conductors are adequately protected from overheating and that the electrical system operates safely and reliably. Another scenario involves conductors installed in an underground duct bank. The temperature in the duct bank can be affected by several factors, including the soil temperature, the depth of the duct bank, and the presence of other heat sources, such as steam pipes. In this case, it would be necessary to conduct a thermal analysis to determine the appropriate ambient temperature for ampacity correction. This analysis would take into account all relevant factors and would provide a more accurate estimate of the actual temperature experienced by the conductor. In some cases, it may be necessary to install cooling systems to reduce the ambient temperature in order to maintain the conductors within their temperature ratings. This is particularly common in data centers and other facilities where large amounts of heat are generated. In conclusion, determining the proper ambient temperature for conductor ampacity correction is a critical aspect of electrical system design and installation. It requires careful consideration of all relevant factors and a thorough understanding of the National Electrical Code requirements. By following the guidelines and recommendations outlined in this discussion, you can ensure that your electrical systems operate safely and reliably. Remember to consult with qualified electricians or engineers if you have any questions or concerns.